Hi everybody, welcome to section 3.1, which deals with graphing linear equations in two variables. So at the end of this section, we're going to be able to plot points, talk about the rectangular coordinate system, how to graph the linear equation by plotting points, and then finding the intercepts and graphing a line using the intercepts. And then, of course, we're going to talk about vertical and horizontal lines. Okay, so first of all, let's introduce the rectangular coordinate system. So each point inside, this is basically a two-dimensional space, okay? And we have here, this is the x-axis, and this is the y-axis, okay? So remember, number line goes from negative infinity to positive infinity, and it has 0 in the middle. So now we're kind of going two-dimensional. We're not just going left to right. We're considering vertical, up and down direction, okay? So we can talk about anything that we use a point to describe the location on this rectangular coordinate plane, okay? And a point looks like this. It has parentheses and it has two values. The first value is considered the x coordinate, or where it lies in the x direction, and the y value is the y coordinate, or where it lies in the y direction or the vertical direction. And let's talk about one of the most important points that exist for this system is right here, the origin, and it's at the intersection of the x and y axis. It's 0, 0, so it's right there in the middle. And then the next thing I want to say is this, the plane is separated into 4 quadrants, and we call them quadrants 1, 2, 3, and 4, obviously. And it goes starting here on the upper right, and then it goes counterclockwise. So it's labeled 1, 2, 3, and then 4 using Roman symbols. Okay, so some things to notice. All the points that are in quadrant 1 have positive x and positive y values. Why is that? Well, that's because, look, on the graph, these are all positive and these are positive, okay? So that would be quadrant 1. So let's say, for example, you had like, I don't know, 5, 5. It's both positive, okay? If a point is positive, a negative x value and a positive y value, that's in quadrant 2, because you can see that the x values are negative and the y values are positive. Okay, so that would be quadrant 2. And then quadrant 3, both x and y are negative. So see here that the x values are negative and the y values are negative. So that's, quadrant 3. And then quadrant 4, the x values are positive, but the y values are negative. So x values positive and the y values are negative, and that's everything that's in this quadrant, okay? Alrighty, so that's that. And then let's go ahead and talk about locating a coordinate. So let's say we want to sketch coordinates 1, 3. Well, that just means if they give us this point here and they say, hey, plot that point on this graph, you say, okay, well, this is the x coordinate. So we know that horizontally, the point is going to lie on the value x equal 1 somewhere, okay? And then we have the y coordinate is 3. So the y coordinate and the x coordinate meet at this specific location, okay? And that is the point 1, 3. Okay, so let's do a couple of examples for fun. So here we have a negative 4, 1. So that means, okay, on the x-axis, I look at negative 4. On the y-axis, I would look at 1. And then where do they meet? They meet here. So this is the point negative 4, 1. And then let's do another one. We have the point negative 2, 3. So negative 2 is here, 3 is here, and they meet here at negative 2, 3. Okay, and then we have 2, negative 5, so 2 and then negative 5, it's going to be here, quadrant 4, 2, negative 5. And then we have negative 2, 5, so negative 2 on the x-axis and 5 on the y meet up here, negative 2, positive 5. And then you have negative 3 and 5 halves, so negative 3 and then 5 halves is 2 1/2. So right there, negative 3, 5 halves. Okie dokie. So, okay, so now you know about graphing points, plotting points, right? Let's look at a couple of graphs of lines and let's notice a couple of things. So here for on the left side, you have the line 2x plus y is equal to 6, and you'll notice that it crosses the x-axis here at 3, 0, and it crosses the y-axis here at 0, 6. Okay, and on the right, you see here 3x minus 4y is equal to 12, crossing the x-axis at 4, 0, and then the y-axis at 0, -3. So interesting. So that leads us to think, okay, well, what about in general? What are points on the x and the y-axis? Okay, so they're also called intercepts, aka intercepts. Okay, so points with a y-coordinate that's equal to 0 are on the x-axis. So let's see here, -2 for x and y is equal to 0. So notice that the x value is -2 and the y value is 0. So they have anything that's on the x-axis, y will equal 0, and then vice versa for the y-axis. Any point on the y-axis, the first coordinate will be 0 because it's a 0 value for the x, and you'll have the number on the y part. So let's do a couple of examples. So here, remember, so we have x, y, 0, x is 0, y is 5, boom, okay, that's 0, 5. B, we have 4, 0, then that means that the x value is 4, and the y value is 0, that's that. Then you have -3, 0, sorry, it's a y, -3 for x, and y is 0 is here. Then you have, of course, the origin, 0, 0 is right there, our favorite. And then 0, 1, so this is where x and y, x equals 0, y equals -1, that's right there, 0, -1. All right, now, can we work backwards? In other words, if I give you the points, are you able to name the ordered pair? And the answer is yes. Of course we can, right? Because let's say here we'll start with A. In order to name this point, we say, okay, well, what's the value of x that it's on? The value of x is -3. What's the value, comma? What's the value of y here? The value of y is 3, and there you go, okay? So let's look at B. The value of x is -1. The value of y is -3, so that's B. C, the value of x is 2. The value of y is 4. And then D, we have the value of x is 4, and the value of y is -4. Okay, and then E, where are you? Here you are. The value of x is 0. And the value of y is -2. And then finally, F, we have here the value of x is 3 and the value of y is 0. Okay, great. Okay, let's talk about linear equations. Okay, so basically, a linear equation is a line, okay, and it has this form ax plus by is equal to c, where a or b are not both 0, and then you have the capital A, capital B, and capital C are all constants, like numbers. This is an example. So if we have x plus 4y is equal to 8, that means that A is 1, B is 4, and C is 8. This is called the standard form, okay? So just get yourself ready, okay? It's super exciting. We are going to look at different equations that describe, lines here. So this is called the standard form. But basically, they're different formulas, but they're talking about the same thing, okay? So don't tell anybody. Just kidding. Of course, tell everybody. All right. So if you have a line, what would be considered a solution for this linear equation? So let's say, a solution would be any and all points x and y that when I plug them into an equation, it gives me a true statement, okay? So that's one way to look at it, okay? So let's say here we want to know which ordered pairs are solutions to this equation x plus 4y is equal to 8. So we have that 0. How about the point 0, 2? Okay, so looking at this here, that tells me that the value of x is 0 and the value of y at this point is 2. So we take our equation, x plus 4y is equal to 8, and then we just substitute, right? So since x is 0, 0 plus, and then 4, and then y is equal to 2, so times 2 is equal to 8. Basically, we're asking, does that? So does 8 equal 8? Yes, it does. And then this is a solution. So yes. Okay, how about B? X and y. So same equation, 2 plus 4 times negative 4. Is that going to equal 8? That's the question. And you have 2 plus negative 16. It's looking like a big heck no, right? So we have negative 14. This definitely does not equal 8. Not today, at least. So that is a no, not a solution, or not a, this is my abbreviation. So, okay. And then C, we have the point negative 4, 3. So plugging it in. Negative 4 plus 4 times 3 is equal to 8, or is it? Question mark. Negative 4 plus 12. Oh, it's looking like a yes, isn't it? 8 is equal to 8. Yes, it is. Today it is. And then yes, this is a solution. All right. A few more words about what does a graph represent. So let's say you have a graph, right, of a line, and you look at this table here. If I was to take every, let's say this table here, we have an example, 3x plus 2y is equal to 6. Okay, and we have these points 0, 3, 2, 0, 1, and 3/2. They all fit this equation. They're all part of it. They all are solutions, right? These 3 points. But a line, every single point is, a line is basically the set of all points x, y that fulfills that solution. Okay, so you can think of the equation, you can think of the equation as describing a set of points, infinite amount of points, because see here, these are just 3 of the solutions. There's like this guy and this guy. There's so many possible solutions, right? Infinitely many, actually, right? Because you could have, point 0.00000021 comma, and then whatever the y one is for that. There's like infinitely many. So it's really cool because it's a beautiful way to describe something infinite. It's very cool. Okay, so if we had the equation and we plugged in a point, if it's true, like we just did, it is a solution. And if it isn't, it would not work, right? It would be false like this. What else? Okay, so here, continuing to say a few words more about graph of a linear equation. Yes, it's in the form ax plus by plus is equal to c. That's right now it is, but it can come in other forms. So notice this one, graph of y is equal to 2x minus 3. It's not in that form, but it's still a line, okay? So let's see here. This is we already said that. Every point on a line is a solution of an equation. Every solution of this equation is a point on the line. Okay, they're kind of like the same thing. Okay, so for each ordered pair, let's decide if it's a solution to the equation, and B, if it's a point on the line. So if A is yes, B is yes, right? And if A is no, then it's no. So let's plug this in. We have x and y. So negative 3 would equal 2 times 0. Does negative 3 equal 0? No. So it's not a solution, and it's not a point on the line. No and no. How about 3, 3? Does 3 equal 2 times 3 minus 3? It actually does. 3 is equal to 6 minus 3. Yes. 3 equals 3 today. And so yes and yes. Yes. Okay. Next one. XY, of course. Negative 3 equal 2 times 2 minus 3. Does negative 3 equal 4 minus 3? Not today, right? So no and no. And then the last one, D, we have negative 5 equal to 2 times negative 1 minus 3. Negative 5 equals negative 2 minus 3, negative 5. So yes and yes. Okay, awesome. So let's do another problem. So can we also figure out solutions by just looking at the graph? And you can. Okay, so that's really nice as well. So let's say here we have the graph of y equals 3x minus 1. And we want to check if this is a solution 0, -1. Now we could do it algebraically like I just did, plugging it in and see if it's true or false. But if you have the graph, you can also just like check on the graph, right? So so let's see here. So let's find the point 0, -1. So 0 here, -1. And it is on the graph, so yes and yes, right? And then B, 2, 5, is this a point on the line? If it is, then it is a solution to the equation. So you have 2 and then 5 up here. And yes, it is. It is a point on the line, so we can safely say, yes, it's a solution to the problem. Let's see here. Now, it works backwards. So if you want to graph a linear equation, let's say you just had the equation and you're like, man, I want to draw this in a picture and it'd be awesome. So you need to be able to, you can find points, okay? And then you can plot them, okay? It's good to use 3 points, and I'll show you. We do that by making a table. And we usually pick 3 values of x and their corresponding values of y, okay? So let's see here. Let's find the equation y is equal to 2x plus 1 by plotting points, okay? So we'll have a table, and we have the value x and y, so x and y. Now, so let's say y equals, which is going to equal 2x plus 1. Let me see here. Yeah. And then the last thing will be, we'll just put them together. Okay. Now, what people usually do, if it's in the form y equal, number times x plus a number, is you pick a few values for x, plug them into the equation, find the y that goes along with that x, and then plot that point. Boom. Easy. It's probably good to pick like a negative value and 0 if possible, and then a positive value for x. So let's say I'll pick -3. So it's basically, I could have picked any value for x, right? It really didn't matter. But the only thing is, you don't want to pick like -10,000 for x, right? You have a crazy value for y, and that's, what kind of graph would that be? So make it close. So then here, so x is -3, so we have y equals 2 times -3 plus 1. That's going to be y equals -6 plus 1, which is -5. So your point xy is going to be -3 and then -5. Okay, so that's, plugging it in. So we have -3, -5 is down here, and then this is the point -3, -5. What if we plug in 0? If we plug in 0 for x, we get y is equal to 2 times 0 plus 1. So y is equal to 1. We have 0, 1. That's a point on the graph. So let's go ahead and plug that. 0 for x, y is equal to 1. That's 0, 1, okay? Then let's plug in one more. At 3, we have y is equal to 2 times 3 plus 1. That's going to be 6 plus 1. Oops, it's going to be a big number. 7, which is off the chart. So let's just, whatever, here, 6, 7. Okay, fine. And now it's back on the chart, on the picture. Okay, so we have the point is 3, 7. So for x it's 3, for y is 7. So 3, 7. Okay, so we've plotted 3 points, and now what do? We connect them. Okay, maybe we should have gone with -2, 0, 2, huh? That's okay. We're good. Okay, so that's your really cool looking graph. Now let's do a couple more. Let's do y is equal to -4x. Okay, so let's do a table here. So we have x, y is equal to -4x, and then we have the point in total. So we can pick, let's go ahead and pick -2, 0, and then 2. So then we have y. So when x is -2, what's y going to be? So we plug in -2 here, and that's going to be 8 positive. So the point that we're going to plot is going to be -2, 8. All right, so that's one of them. What about when x is 0? What's the value of y? So y is equal to negative 4 times 0, which is 0, of course. So then that's the origin. Okay, 0, 0. And then what about, what is the value of y when x is equal to 2? So we have y is equal to negative 4 times 2. Y is equal to negative 8. Oh, so even then it was a lot. Oopsies. So then we have 2 and then negative 8. Okay, so it looks like we need to add some points here. So this is 6, 7, 8. Sorry, I'm not like the best at drawing. And here we're just going to be kind of 6, 7, 8. This is, I'm just going to say 7, and then this is negative 8. Sorry. Oh my goodness. That's okay. This would be negative 6, this would be negative 7, and then this one will be negative 8, this value right here. Okay, so we have negative 2, 8, so negative 2, positive 8. You see, this is what I just said. Okay, yeah, here, negative 2, positive 8, negative 2, positive 8, boom, 0, 0, right through the origin. And then the last one, 2, negative 8 is down here, and then we connect the graph. And then there it is. Okay. All right. Let's talk about vertical and horizontal lines next. So vertical line is just a line that goes straight up and down, and it has the form x equal a. So it's a little different. There is no y value. Okay. It passes through the x-axis and it never crosses the y-axis. I mean, unless it's the line x equals 0. Literally, the y-axis is the line x equals 0. But let's go ahead and do this here. Let's graph x is equal to 2. So basically, when you say x is equal to 2, it's all the points in the in this coordinate system that where the x value is 2. So it's literally just straight up through 2. Okay. So if you see here, so this point right here is 2, 1. This point is 2, 2. So it kind of like doesn't even matter what y is, because it's going to be that every single possible value of y. X will always be 2. Okay. All right, so that's vertical lines. What about horizontal lines? Horizontal lines, as you can imagine, it's different. It has the form y equals b, no values of x here, right? So let's say here we want to graph the equation y is equal to negative 1. So where does y equal negative 1? Right here. And then we just go ahead, boom, horizontal line, y equals negative 1, okay? All right, so next we're going to have a graph y equals negative 3 and y equals negative 3x, so you can see the difference, okay? So y equals negative 3, we already recognize, oh, this is a horizontal line, that's fine. Very good. Going through negative 3, so that's y equal negative 3. What about y equals 3x? So let's say I want to do a little charty chart. 3x here, okay, fine. So I'm going to pick negative 1, 0, 1, okay? So the y value will be negative 3 times negative 1, which is positive 3. So the point itself will be negative 1, comma 3. Okay, fine. What about 0? If I plug in 0 for x, I get y is equal to negative 3 times 0, which is just 0. So you get an origin point. And then if x is equal to 1, y is equal to negative 3 times 1. So that's going to be 1 comma negative 3. And there it is. So we have these 3 different points. So notice that it's different. So negative 1, 3 goes up here, 0, 0, and then 1, negative 3. So you see that 1 is a line, which later on we're going to talk about slope. This has slope negative 3. And then the other line is just a straight up horizontal line going through the, crossing the y-axis at negative 3. So earlier we talked about points on the axis, either axes. They're also more commonly known as x and y intercepts. Okay, so the x-intercept has the value y is equal to 0, and the y-intercept has the value x equals 0, yeah? So let's go ahead and do that. So what that means is you can easily use a table to find them, okay? So let's say given a graph, can we find the intercepts? Well, they're right here. Here you go. Here's one. Here's another one. So we have the point, 0, negative 2 is here, and this is the point 2, 0. So we would say something like, you know, y-intercept, you can either say y-intercept is negative 2, x-intercept is 2. Or we could say y-intercept is at, and then you would do 0, comma, -2. Or you could say, 2, 0. Okay. We have 2 others here. So this would be the point 0, 2 here. This is the y-intercept, right? Because it crosses the y-axis. And then here crossing the x-axis is 3, 0. That's the x-intercept right here. Okay. So what if we didn't have the graph and we wanted to find the x and y-intercepts? Never you mind or fear, because what we do is we create a table, we let x equal 0, and we let y equal 0. So what I'm going to do is I'm going to show the work to the side. So let's say here I have, okay, I want to find the y-intercept, so I let x equal 0. So if x equals 0, I get 2 times 0 plus y is equal to 6. This is going to become 0, so you just get y is equal to 6. So boom, I'm going to write that there. Then I'm going to let y equal 0 to find the x-intercept. And then this is the x-intercept. Notice that you make the opposite, 0. Intercept is spelled like this. Okay, yeah. Okay, so y equals 0. We have 2 times x plus 0 is equal to 6. So 2x is equal to 6 divided by 2. X is equal to 3. Okay, there it is. So the intercepts are 0, 6, and 3, 0. Okay. Let's see what else. If we want to graph an equation using the intercepts, we do the same thing. We start off with a table, right? And we let x equal 0, y equal 0. And then we let x equal 0 first and solve for y, And then we let y equal 0 and solve for x. And then if we want to plot a third solution, you can. But a lot of times the intercepts is just fine. But sometimes you're going to get something that goes through the origin. So it only has, when a line goes through the origin, it only has the x and the y-intercepts are both the same one. So it's a little, you're going to need more points, okay? Well, anyway, so here we have negative x plus 2y is equal to 6. Let's let x equal 0 to find the y-intercept. Intercepts, we're finding that. So we have negative 0 plus 2y is equal to 6. This is going to be 0. 2y equals 6. Y is equal to 3. Equal 3. So then boom, right here. And then to find the x-intercept, I let y equal 0, okay? So negative x plus 2 times 0 is equal to 6. This becomes 0, so negative x is equal to 6. Divide by negative 1 to get rid of it. So then you get x is equal to negative 6. So that goes over here, negative 6. So now we have the point 0, 3, and negative 6, 0. Okay, so 0, comma 3, it's up here. That's the y-intercept. And then we have the x-intercept at negative 6. So it's just over here, negative 6. Okay, negative 6, 0. And this is 0, 3. Then we just draw a line through it, and there you go. Sorry, it looks messy. Let me erase this part. Yeah, so you can see. Okay, so this is, negative 6 right there, okay? So it crosses here and here. Great. And that's it for 3.1. Yes, good luck, happy studying, and I will see you on the next video.